Welcome back to our next lesson, everyone. We're going to continue with the topic of symmetry for this lesson right here. There's a couple of things we need to look at. We're at page 33 right now, and I'd like to give you a couple of definitions for types of functions. One is called, let me get my pen going here. One is called an even function, and the other type is called an odd function. Now, basically, they relate closely. In fact, they're exactly the same as what we just did. An even function is a function that's symmetric with respect to the y-axis, and an odd function is a function whose graph is symmetric with respect to the origin. So those two definitions are just basically what we did for two of the tests anyway in the last lesson. How do you determine if a function is even or if a function is odd? Well, like I say, they closely relate to the tests that we just did in the last lesson. To tell if a function is even, here's what you should do. Replace x with negative x, which is what we did in the last lesson, and see if you end up with the exact same function that you started with. If so, the function is even. To tell if a function is odd, you basically do the same thing. Now, this test might look a little different from what we did last day, but really it's the same test. Replace x with negative x again. So for both tests, that's the replacement that you make. And then look carefully at the function you end up with. If every term is the opposite sign of the function that you started with, then it's an odd function. Okay? So let's look at a couple of examples right here. Example number 16. Now remember, all we need to do here is replace x with negative x and carefully look at what we end up with. So the test, let's look at part A. Let's work out f of negative x, and let's see what we end up with. All right, so let me see. I'll replace the x in the first term with negative x, and I will also replace the x in the second term with negative x. And let's see what we get. Now, of course, a negative term cubed, or a negative number cubed, remains negative. So the first term will become negative x to the power of 3. And then the second term we have subtract negative x, and that will turn into plus x. Now, this is the only test we need to do to determine if that function is even or odd. But compare that to the original function that we started with. And let me see. Well, the x to the power of 3, that changed sign. And the minus x, well, that changed sign as well. So in other words, this function here, what we ended up with, is the negative of the function that we started with. And therefore, this function is odd, meaning it will be symmetric, its graph will be symmetric with respect to the origin. Okay, now let's look at B. We have a different function here now, but again, the only replacement we need to make, I'll put a g there now. So g of negative x, let's replace all the terms with negative, and let me see, there's only one place there to put negative x. All right, so let's see what we end up with here now. Of course, if you take a negative term and square it, it becomes positive. So that will become positive x squared. And of course, the plus 1 doesn't change. And look at what happened. Compare that now to the function that we started with, and I can see that it's exactly the same function. Nothing changed. So this is what we call an even function. All right? And that's the only test that's required to tell if something is even or if it is odd. So the practice 16 on the bottom of that page, I'm going to leave that for you to try. Determine if the following functions are even, odd, or neither. It's quite possible they could be neither of those two. So just try those, check your answers with D2L and see how that works out. And another thing I'd like to get done in this lesson, this begins on page 34, and this is called graphing functions. When you're graphing functions, especially if you're making a table of values, you have to look at the function carefully to see if it's symmetric with respect to either of the axes or if it's symmetric with respect to the origin. because that can really help you when it comes to graphing these functions. Now, the first two examples here on page 34, these are relatively straightforward, really easy. What they want you to do for example 17 for part A is complete the graph with y-axis symmetry. So in other words, we have a curve there, like a black curve. They just want you to reflect it in the y-axis so that it appears over on the other side. Now, actually, that shouldn't be too bad. All you really need to do, you want to be fairly accurate. Look carefully at the graph that you're given. Look at the graph that you're given and see if you can pick out some of the points, some of the coordinates that are on that graph. So for example, right here, if you look at that point right there, okay, that's at the point 1, 1. All right. Well, if it reflects across the y-axis, then that means the x-coordinate will change. So negative 1, 1 is going to be a point on the reflection. So about right there. Okay, so that's where that point reflects over. Now, if you look at some other coordinates and change their signs as well, that's one way to do it. Or an even simpler way, just watch this. Look at this point right there. Okay, now I can't really tell what the x-coordinate is. It looks like about 0.5, but I can see that the y-coordinate is 2. How many blocks away from the y-axis is that point? Well, if you count carefully, 1, 2, 3, 4, it looks to my old eye like it's 5 blocks away. So on the other side of the y-axis, again, 5 blocks away, approximately there, okay, approximately there, there's going to be another point on the reflection. And if you try this a few more times, like take this point right here, that looks like it's about a little over 3 blocks away. Well, so your point is going to end up approximately there. And what about a point down here? Okay, you see where you have 4, that's at 4. And how many blocks up is that? Approximately 2.5 blocks up. So come over to negative 4 and go approximately 2.5 blocks up, and there's going to be another point. And anyway, once you have a few points, then you can just, as carefully as you can, but it's important to show the points, draw your curve through those points. And, well, approximately, that's what it would look like. Okay? For B, down below that, same thing. Complete the graph with origin symmetry this time. All right, so let me see. Let's pick out some points. How about, like there's a point right there. Okay, now it looks to my old eye, 1, 2, 3, 4. Every one of those blocks is about 0.05. So that x value right there is approximately 0.25. So if you go negative 0.25, 5 blocks in the other direction, and go down to negative 0.5, because remember the x and the y change sign. For origin symmetry, there's going to be another point on your graph. Let me just move down a little. Let's pick out a few more. Let's try, I can see 1. Look at that. 1 and 1 is another point on that graph. So at negative 1 and negative 1, there is a point on the portion of the graph that's symmetric with respect to the origin. And you can get a few more. All right, let me see. How about if I came over to 0.05, 0.6, 0.7? Let me try 0.7. And that value right there, that's 0.7. And that value right there looks like it's about 0.5, 0.6, 0.7, 0.8. It's a little bit above that value right there. 1, 2, 3. Okay, so that's a little bit above 0.6. So at negative 0.7, which is about there, and at negative 0.6 approximately, 0.5 or 0.8, I mean, about there, that should be another point. So we're looking approximately there. Okay, now watch. Once you have a few points, draw the part of your curve. I can't do a really good job with this stylus, but that's what the graph is going to look like, all right, when it's symmetric about the origin. So just pick some points that are on the graph. Sometimes the scaling is good, sometimes the scaling is not so good. You may have to estimate some points, but you can always find a few points that you can reflect over. And there's one more question here I want to have a look at with you. Here's question C. Now this is on the top of page 35. Now they want you to graph this function right here. Okay, and I can clearly see that they've already scaled my axes, 0 to 5. That looks like 10 blocks. So there's 1 right there. There's 2. There's 3, and so on. All the axes are scaled that way. If you were to make up a table of values, watch what would happen if I just put in some positive numbers here for now. Now you're not going to need very big numbers. Try 0, 0.5, and 1. All right. Now if you plug, notice I only pick positive numbers. There's a reason for that. Find your y values. Well, if you plug 0 into your equation for x, you get back 0 for y. If you plug in 0.5 for x, you're going to get back, I've already got the calculations done, but you can type them into your calculator. You're going to get back 0.75. And if you plug in a 1, you're going to get back a 3. Okay, well that's pretty good for the positive side. We have 0, 0 right there. We have 0.5, which is half, which is 1 block over. And 0.75, let me see, that would be approximately there. Okay, and then I have 1, and I have 3, so it's actually fairly sharp. In fact, remember now it's a cubic. You know that you're going to get a sideways S shape. But what about on the negative side? Well, if you look at that graph carefully, watch this. Let's do that little test to determine if this function is even or odd. Let's replace the x with negative x, and let's see what happens. So that becomes negative x cubed plus negative x right there. So this becomes equal to, golly, look at this, negative 2x cubed minus x. And do you notice that all of the signs have changed? So therefore, this is an odd function. Okay, that function is odd, which means that you can now determine some other points that are on that graph just by changing the x and the y signs. Remember, that's what an odd function does, right? The x and the y are both changed. So yes, you have 0.5 and 0.75, but now I also know that negative 0.5 and negative 0.75 is on my graph as well. So in other words, it's symmetric with respect to the origin. So that's going to be a point about right there. Excuse me. And also negative 1 and negative 3 must be on that graph. So negative 1 is there, and negative 3 is actually 6 blocks down. And your point is approximately right there. Not very good with this stylus I have, but watch. There's one side. And now just by realizing that it's an odd function, I have some points on the other side as well. And there's what your curve looks like. It's just a way that you can shorten the actual amount of work that you do in drawing a graph, making up a table of values, if you note carefully what type of a function it is. If this function had been symmetric with respect to the y-axis, in other words, if it was even, well, I still could have come up with some other points there just by changing the sign of the x-coordinate, all right? So that's it for this lesson. I'll stop there. Try practice number 17 on page 35 and also on page 36. Excuse me. And I think that's it. Okay, so we'll stop there for this lesson, and I'll get the next lesson ready now. The next lesson is on something called translations. And a translation, a graph is translated if you just move it. You physically move it from one place to another. So that's going to be the topic of our next investigation. Okay, so I'll stop there. Bye-bye for now.